So what you're looking at here is a measure of reflected light that's coming from Ceres. So when we talk about spectroscopy, essentially what's happening is light is bouncing off the surface of Ceres and it's being returned back, reflected back towards the Earth. When you use a spectrometer, you can basically add up the strength of the reflection over the individual wavelengths of light. So that's what this is showing. This is showing a region from the visible to the near infrared. And if you look down kind of at the bottom, there's a guide. It says 0.3 all the way to 3.6. Those are wavelengths of light, so the actual wavelength of light in microns or micrometers. So if you look over at the little number, there's a number that says 3.0. If you look up above that, you'll notice that Ceres and Pallas, their spectrums are doing two different things. In both cases, what's happening here is that's a spectrum that's telling you water has been involved in the creation of the materials on the surface. If you look at Pallas's, it's kind of making a V like this. It's kind of making a steep arm. So that steep arm is actually telling us, so yeah, actually I'll do it this way. That steep arm is actually telling us that that's water of hydration, which means that there's little OH molecules tied up in the surface materials on Pallas. Tells you water was there at one point in time. It might still be buried deep below, but it's not really a part of the materials right now. If you actually look at Ceres 3-micron spectrum, you'll notice it looks kind of like a U. So that was actually the first indication that Ceres was totally different from anything else in the solar system. If you look at a pure spectrum of water, it looks a little bit more like this in that 3-micron region. It's not perfectly like Ceres. Ceres is much more flat and broad, kind of like this. It's got some interesting features. And that little dip kind of out to the side over by 3.3, that kind of, there's a, so there's a one at 3, and then it kind of has an arm that does this over at 3.3. So if you look at that, that place is actually what Julie was talking about. It's actually a detection of kind of carbonates that are involved in the surface materials on Ceres. So what that tells us is that there's actually water kind of bound, making a clay almost, on the surface of Ceres. One of the things you've probably been paying attention to is the Curiosity rover. It's been talking a lot about water minerals on the surface of Mars, carbonates. Oh, it's so exciting. Well, this is all literally bathing the surface of Ceres, so it's covered in these materials. And so it's a way for us to actually add that up, that Ceres, okay, so far we've got that its mass and size is telling us it's made of like half water. And then its spectrum is telling us, hey, there's a lot of material here that involves water all over the surface of Ceres. Now, it's not water ice. That's what makes it so different. So we're kind of in a situation with Ceres where you could say, don't judge a book by its cover, or don't judge Ceres just by its surface composition. That it's just because we don't see water ice right there doesn't mean it's not very close. So we think this actually means is that impacts and activity on Ceres' surface has created a layer of material that's a mixture of some of its original material and material falling down in the asteroid over the course of 4.5 billion years of solar system evolution that's creating this mixture of water-rich materials that we find on inhabited planets like the Earth and on potentially habitable Mars. So it's a unique thing that Ceres has going for it.